So on to the heavy stuff here in the last few minutes before I open it up for questions is iLogic. I've said this for a long time. iLogic is a window to the Inventor API. So if you want to really truly use iLogic at a high level, at an expert level, you need to do two things. You need to understand not only Inventor, but you need to understand the Inventor API as well. And the Inventor API, the help for it can be accessed right inside of Inventor. If you're new to the Inventor API, this is a great place to start. Kind of explains what the API is, what's new in the Inventor API, the user manual, different overviews of getting started with the API, general concepts, things like that. But then you get down into here into the actual object model, and this is where it kind of tells you exactly what you need to do step by step in order to do something. Like as an example, if I want to do something with drawing sheets, let me look up sheets here. So if I go to the sheet object, this is where inside of the API where if I need to activate a sheet or add a border to a sheet or add a title block, or if I want to do something with center lines in a sheet or the name of the sheet or the orientation, these are the different methods and functions I can use or leverage in order to use the Inventor API to make those things happen. Okay, so if I go back here to iLogic, you'll notice as in this example right here, whenever I write my iLogic code, I always do it in such a way where it parallels how I would do it in Visual Basic and how I would do it to affect the Inventor API. I very rarely use any snippets at this point, simply because if I want to run this code inside of Visual Studio, I can basically do a copy and then paste there, and with minimal amount of tweaking, I can make this code run inside of Visual Studio as well as iLogic. So it's a very important thing to understand that, simply because if I want to write straight VB code here in iLogic, I can, but I can also write that inside of Visual Studio. And the reason why I might want to do it inside of Visual Studio is because then I could take advantage of Intellisense. And if you're new to writing VB code, Intellisense is just a mechanism inside of Visual Studio to ensure that the code that I write is accurate. It removes the opportunity for error when writing code, simply because if you're familiar with any type of code language, punctuation, capitalization, all of that is extremely important to ensure that your code runs accurately. So if you make a small little error, the code may not work whatsoever. So by using Visual Studio, it gives you those tools necessary to ensure that you write your code accurately with minimal amount of error. Now, inside of Inventor, we can also do that in iLogic. So since Inventor 2018, there is capability here inside of iLogic that if you hover over things, it's going to give you this little kind of window to kind of explain what is actually happening. So if parameter, well, what is a parameter? A parameter value is a string object, and it gets or sets the value of a parameter. If the parameter is numeric or unitless, the value will be in the document. So it kind of gives you a heads up as to what is actually happening. Like this line right here. I'm declaring a document as a drawing document, and it equals this application documents open, and then what do I want to open? Well, it's telling me I need to provide a full document name as a string, and then I have an optional variable as a Boolean, in this case false, if I want to open that up visible. Okay, so Intellisense, kind of like Intellisense inside of iLogic as well as Visual Studio. So very helpful information if you want to start generating your code here inside of the iLogic rule editor as well. Going back over to my PowerPoint. So take advantage of Intellisense. Start learning the Visual Basic.NET language. It will help you when you write your iLogic code. Follow code writing best practices. I cannot express this enough, guys. I understand if you're just starting off on iLogic, it's kind of complicated to wrap your brain around all these concepts. But as you become more and more familiar, understand about what is Camel Case, writing Camel Case, writing your code in a big ambiguous fashion. And what I mean by that is Camel Case is creating parameters that follow a particular convention. And I don't think I see anything. Well, okay, so shared variable current path. This is Camel Case. And what I mean by that, let me kind of go down here, is if I want to declare a variable, I could say something like, if I wanted to create a variable for file name, I could say file underscore name. That's not Camel Case, right? Camel Case is when you capitalize the first letter in a word, and then you capitalize all subsequent words. So file name and path. Now, that would be an example of Camel Case for a variable that is descriptive for me to understand what that variable is supposed to hold, as a string equals string.empty. Okay, so I'm declaring a variable called file name and path. It's going to be of the string type, and right now it has no value. It's an empty value. And then I can go back and say something like file, or if I want to do a copy paste, is probably the better way to do it. Control C, Control V equals, and then I can give it a string value, a value like C, backslash, whatever the case might be. Okay, so Camel Case is an example of writing out your variable names that are descriptive. When you read it, you can understand what it is. You're not using underscores and you're not using any spaces, and you're clearly identifying what that variable is by capitalizing the first letter, and any subsequent words those are capitalized as well. So I can't express that enough. It makes things a whole lot easier when you're starting to read other people's code. And really, that's the important thing here, is by following code writing best practices. A lot of the time, if you're the one that's generating or writing the code, you may not be the person that has to edit it later on. Do your friend a favor. Follow best practice, writing best practices, so that way anybody who has to use the code can understand what it is and what it does. Ambiguous code follows along the same path. And what I mean by that is you don't want to hard code things in. You want to be able to create functions and subroutines that you can repeatedly use to avoid redundancy. So like in the case of this rule right here, I have a function called select template. So whenever I want to select a template, all I'm going to do is just call that function. So I can reuse it over and over and over again. So I just pass a value to here, or I call that, it does its work, and then it returns some sort of value, so that way I can do something. I have other rules here that can do the same thing. So if I go to my drawing here, like create sheets, if I ever need to delete a sheet, I can just call this function. If this was a function, I could just call that over whenever I needed to delete a sheet, or whenever I need to add a view. I have different functions like delete a view. So any view that I need to delete, I can just call this function over and over again, and it's going to do whatever I need it to do. So it's like a helper function. And then typecasting with a value. And what I mean by that was exactly what I showed previously. Typecasting is a means of identifying what this is. So like index as an integer, or sheet, O sheet as a sheet. So I'm declaring a variable, I'm telling it what type it is, and then I'm giving it a value. So I see this a lot where individuals would do, something like this, where dim O sheet as sheet, and then they come back and say, O sheet equals something. Well, you don't necessarily have to do that on 2 lines of code. You can do it on 1, simply by declaring your variable, typing it, giving it a type, and then giving it a value. And it makes things more consistent in your code, and it reduces opportunities for errors within your code as well. So just some writing best practices: Camel Case, function subroutines, and typecasting.